Hey Geometry, moving on to lesson 23. I hope you enjoyed multiplying and dividing expressions with radicals. If you had a pretty good grasp on that lesson, then lesson 23 should be a breeze for you. If not, we may need to slow down and go back and go through lesson 22 again, because it's really the building blocks for working with radicals. Alright, so let's get into it. Simplify each expression as much as possible. This is sort of a review of yesterday's lesson. Lots of different ways you can do this. I usually break it into factors. So 16 times 2, 16 is a perfect square, so that can come out of the radical. And I'm left with 4 square roots of 2. 45 breaks down into 9 times 5. 9 is a perfect square, so 3 square roots of 5. Yesterday I may have broken this down into 3 times 3, and I said if there are two that are the same, then they get out of jail, but we're in the second time we've done this, so I'm taking it back one notch and pushing you guys to do a little on your own. 300 breaks down into 100 times 3, and 100 is a perfect square. And we have it. Okay, we simplified. Okay, here we have the triangle shown has a perimeter of 6.5 square roots of 2 units. Make a conjecture about how this answer was reached. Well, if I just look at the numbers in front of the radicals and add those together, 2 plus 5 plus 1.5 would be 6.5. And it looks like all the radicals just sort of hang out along with the coefficient, if I call it that, and we get our answer. Okay, that's what it looks like. Let's look at number 5. The sides of a triangle are 4 square root 3, square root 12, and square root 75. Make a conjecture about how to determine the perimeter of this triangle. Well, if I'm trying to add all these things together, if I look here, I could add all of those coefficients or numbers in front of the radicals together because every side of the triangle had a radical 2. Okay, they were all the same radical. So if I can get these to the same radical, then maybe I can add them together too. So let's see if I can simplify these. This is 4 times 3 and 25 times 3. So this is 4 square roots of 3. 4 is a perfect square, so 2 square roots of 3. And 25 is a perfect square, 5 square roots of 3. So if I add together, I mean, they're sort of like the coefficients. 4 plus 2 is 6, plus 5 is 11 square roots of 3, being the perimeter. Alright, circle the expressions that can be simplified using the distributive property. Be prepared to explain your choices. So what we're going with here is, let's just look at this one and then we'll move a little faster. Distributive property means that I can factor out the square root of 2 and just do 8.3 plus 7.9, if you can read any of my handwriting. Okay, I factored out the like term. I've got the whole numbers here not whole numbers, sorry, the coefficients, for lack of a better way to name it, to add together. So I can do that. 13, for this next one, 13 is a prime number, so I will not be able to simplify that radical any. Doesn't work. Square root 5, square root 45. This second one simplifies to 3 square roots of 5. This is why I said that last lesson is so important, because if you're not sure how to simplify radicals, then things are going to get a little harder for you. So 45 is 9 times 5. 9 is a perfect square, so I can factor out a 3. I don't know why I wrote 3 there. So my radicals are the same, so that one I would be able to simplify using the distributive property. This last one, I can simplify those two, but not that one. This one right here, 8 does simplify to 8 is 4 times 2. 4 is a perfect square, so that's 2 square roots of 2. it would actually be 4 square roots of 2 because of that 2 there. So that works. This one does not. 11 is prime. 7's prime. 10 doesn't simplify anymore. 12. So the square root of 12 is 4 times 3. So 2 square roots of 3 minus 75 is 25 and 3. So 5 square roots of 3. That one works. 32 is 16 times 2. So that'd be 4 square roots of 2 plus square root of 2. That one works. And 26 is 2 times 13. But I can't factor that 2 out. So that one's actually not going to work. All right, cool. We explained our choices by showing, excuse me, which radicals can be simplified to get the common radical. Okay, if both terms have the same radical, the same number underneath the root, then we can combine like terms. Really quick, when I say things like I can combine like terms, if we have, to go back to one of the earlier examples, 1.5 square roots of 2, 2 square roots of 2, and 3 square roots of 2, that equals 6.5 square roots of 2. It's just like saying 1.5x plus 2x plus 3x equals 6.5x. Okay, that's why I was calling those coefficients. Square root of 2 is a real number, but we just aren't going to add those together. Well, let's give you another example. If I had, let's go back to another one we just did. Let's do this one. 11 square roots of 7 minus 6 square roots of 7 plus 3 square roots of 2. I can combine these together. 5 square roots of 7 plus 3 square roots of 2, and that's as far as I can take it. That's sort of like saying 11x minus 6x plus 3y. That would give me 5x plus 3y. Okay? If we actually put it into our calculator and crunch the number square root of 7 and square root of 2, we're going to round a little bit here and there, and it's just not a good idea. To get the most exact answer, we just keep our radicals in the most simplest form, but we do not change them into a decimal number. Okay? Okay, explain how the expression 8.3 square roots of 2 and 7.9 square roots of 2 can be simplified using the distributive property. Basically, each term of the expression has a common factor. Okay, my common factor is the square root of 2. Because of that, the distributive property can be applied. It's not generally how I do the math, but you can. So I can take 8.3 plus 7.9 square roots of 2, add those together. I have 16.2 square roots of 2 as my answer. I think I do it more in my head than actually use the distributive property, but that's okay. Here, oh, this is the one I just did. That's funny. I can use the distributive property for the first two terms, but not that third one. Okay, I don't have a common factor with the square root of 2. Okay? Explain how the expression 19 square roots of 2 plus 2 square roots of 8 can be simplified. Well, the second term can be simplified a little bit more. 8 breaks down into 4 times 2. 4 is a perfect square. So I have 2 times 2 square roots of 2. What I did is I took the square root of 4, wrote it right there, but I can't forget about the 2 that was already there. So here we have 19 square roots of 2 plus 2 times 2 is 4 square roots of 2. Gives me 23 square roots of 2 as an answer. So again, I didn't use the distributive property. Let's go ahead and show you that. Okay, we have to simplify everything first, be with the rules that we learned last lesson. And then we can go ahead and use the distributive property to simplify further. Okay, example 3. The expressions in this example have been taken from the list of the ones that you just did. So if you circled them or if you did not, this is where we're sort of explaining why. On this first one, can the expression square root of 7 plus 2 square roots of 10 be simplified using distributive property? No. Okay, I can't break this one down any further. I can't simplify it any further. And 10 is 2 times 5, but neither one of those is a perfect square to get out from underneath the radical. So I'm not going to have a common factor with either of these terms. To determine if an expression can be simplified, you must first simplify each of the terms within the expression, then apply the distributive property or other properties as needed to simplify the expression. So I tried to simplify this to get a common factor, and I couldn't find a common factor. And that's the lesson. That's awesome. There are a lot of problems in your problem sets that have to do with finding area and perimeter. Okay? As a reminder, perimeter is the distance around something. Okay, add all the sides. And area, for instance, area of a triangle is 1/2 base times height. Area of a triangle, and the area of a rectangular square, you can get that. Area of a rectangular square is base times height, or side times side. Okay, so you're going to have to do a lot of simplifying using the rules from last lesson, but I thought this lesson was a lot of fun. That's it.